Hello and welcome to the Object-Oriented Programming with ABAP section. Within this particular section, we will see how the Object-Oriented Programming is present within the ABAP. Now, if you have already the experience with the Object-Oriented Programming with Java or C++, then it will be very easy for you to map those concepts of OOPS, because in ABAP, the concepts are also somewhat similar and the implementation is where you will find differences, but it will be much easier if you have already certain experience here. And if you don't have experience, then that is also okay, because we are going to start from the very basic of what is OOPS and how as a developer your mindset changes when you try to create object-oriented programming patterns or when you try to implement a solution in object-oriented ABAP. Okay, so before we actually start, I would like to give you some of the background here just so that you are ready with the mindset. Now, if you already have basic idea about what is encapsulation, what is objects, what is this blueprint of class, and what is a data abstraction, then you can skip this section or fast forward this particular section. When we try to solve a problem with our code, then how we actually try to structure this code is based out of our mindset. Now, our mindset can be that, okay, I have this requirement and I will divide this requirement into multiple functionality or small functionality, and this functionality I will try to achieve with a function 1, and this functionality I will try to achieve with a function 2, and so on. There can be n number of functions involved, and it can happen that this function 1 will again have smaller subparts, and these subparts will be again small function in itself. So these are functional paradigm of solving a problem, and this is FN para, short for functional paradigm. So the mindset here is that you divide the bigger problems into smaller problems and try to solve those with certain functions. In object-oriented programming, the mindset here is to create a class, and that class represent a real world entity. So for example, if I have a car, then you can have a class car, and this car can again have object like the car 1, the car 2 and 3 and so on. So there can be multiple objects which can be created out of this class. So this class is acting as a blueprint, and out of this blueprint we create our objects, which can be like you are having your frame, and based on this frame you are creating the actual thing, which is the objects. Now this is the mindset which we follow. We try to map the real world entity as the class, and that class are basically defining the properties of that entity. So for example, the class can have a color, so the car can have a color, so we have a color. We have certain specification of width, height, and all those. We have what is the car type, what is the engine type, and there can be multiple other similar properties as well. And also it can have methods, which is more like the function which are part of this particular class. So I will call this method because that is the technical name what is it referred to. So method actually can be the functionality with this class which can be invoked. So I can call this method and I can do certain activity. For example, I can book a car, I can purchase a car. So that can be some methods which is part of this particular class, and I can invoke those method, and that method can do certain changes in the value of this properties or can do certain other activities as well. Now, just to summarize what we have discussed here, we have discussed that in the object-oriented paradigm, we have the classes which are created, and these classes represent a real world object most of the time. So that is what the mindset is, and it is much easy then to map things and create a big project where you are trying to implement certain functionalities, and you know, okay, what are the real world entities I have this car, similar to that I have a person, so I have employees. So these can be mapped directly as a class within the object oriented concept, and this class can then have certain properties which will be like your variables, and then there are methods which will be like your function. And this class can have object created, and these objects are created in memory. So objects are instance of that particular class. So class act as a blueprint which says, okay, how the object should be created, and this object will then be having values of the properties and will also have the method called to change the value of that particular property or do other functionality. This is just the overview in a nutshell what is object-oriented programming. Now, what is the benefit of the object-oriented programming? Now, one of the clear benefit we can see from this particular section, from this first slide itself, that when we map the requirement into your software world, then it's much easier to identify what can be different classes which are created. For example, if you are creating a project and you find out different entities of that particular project. So if I have a project of, imagine a learning management system. Within that learning management system, I can have a student. So this will be the student, and I can have instructors who are teaching and creating courses. So there can be multiple other roles as well, but for these two different roles, I can have one class. And for this instructor, I can have one class, and student can have, okay, what kind of enrollment they have. And for instructors, they can have, okay, what kind of courses they are teaching. So this can be different variables. And then I can say, okay, create courses will be a method within that particular instructor class. And in the student, the enroll into a particular course can be a method. So the mapping of a real world problem into software world becomes much easier, or is relatively easier when it comes to object-oriented programming. It's relatively easier to identify for a new developer also, okay, what is the requirement in the real world and how it is mapped into the program. So that is the one benefit which you will see in the object-oriented programming. Now, the other benefit, which are more like a technical in nature, when we create a particular class, then we can have data and functions which are called methods here, and we'll write methods, and the data and the methods can be encapsulated and can be part of this class. So we are trying to bundle together the data and the functions or the methods within a class. So we are wrapping it. So that is one benefit. You don't have the data and the function separate. You have both together wrapped in a class. So that provides additional benefit when the software becomes complicated, that the management of the particular project becomes easier. And you also have the capacity where you export functionality to the outside world which are controlled. So you have certain public section within the class which are accessible from the object, and the objects are created for that particular class, and the public section outside of the class can be accessible, and there are certain variables or properties which are not accessible from this object. So you cannot access the private section, and there are some protected section which are relatively accessible. So you have a varying degree to control what kind of data is visible to the outside world, what kind of data they can change, and what kind of data they cannot change, which are part of this class. So that particular control also you have in the design time. So you are providing a mechanism for the outside world to change the object, certain properties, with the public and certain properties which they cannot change with private. So you are also creating a level of control which you have within the object or which you have within the class. You control the data, visibility or accessibility. Now you can also refer this as control, or you can also refer to as data abstraction. So I will say, okay, this is also a popular keyword, abstraction. You are abstracting certain data of the object with private and protected section. So you are only providing the functionality or methods or property which one would require to work with that particular object, and you are maybe not providing or exposing unnecessary detail out of the class. So as a developer of this particular class, you may be working a lot to create and implement multiple scenarios which other might not be interested in or which others might not be using. So you are abstracting unnecessary details which is not required outside of this particular class. And when you create the object, then this object will not be able to access the private and have limited access to the protected section of that particular class. So you are also in a way providing the data abstraction feature with this object-oriented patterns. So one more benefit you will find that in your object-oriented concept, you also have a concept of inheritance. So inheritance. Within this inheritance, you have the capability to copy features which can be data and method of an existing class. I can inherit from the class 1, and if the class 2 is inheriting from class 1, then the class 2 can copy the data or the properties of that particular class 1 plus the methods I can copy from the class 1. And I can also add more properties here. So I can basically have more properties here and more methods, and I don't have to really rewrite those which are present already in the class 1. So I can copy certain features from an existing class by inheriting from that particular class, and I can add more properties and more methods or functionalities to it as well. Now it can also happen that if there are existing methods which I have, then the way this method function with the new class can also be changed. So the implementation of that particular method can also be changed based on the requirement if you have, which allows us to not rewrite the existing functionality but just to inherit from it. These are some basic concepts related to your object-oriented programming, and these are general concepts not related to ABAP specific, but in general these are the concepts. And when we go into programming, then we will see in details that how in ABAP the implementation syntax are present, and we will also work with those. So let's go into the code and also learn there how these object-oriented concepts are implemented or are present. So let's catch up in the next section where we will see the hands-on for the object-oriented programming part. Hello and welcome to our ABAP object-oriented hands-on section. Now here the first thing which we will create is we will create a sample class, and the way to do is we will select this package where we want to create this class and new, and we see here ABAP class. Now if we don't see here the ABAP class, then we can just go to the other and search here class. So how we got here, we right click here, new, other ABAP repository object, and here class and ABAP class. And here what we can do is we can name our class. Now when you're creating the class, the prefix normally is selected as CL, and if you are creating the custom, then ZCL. Now it can be ZCL or Z_CL. Now based on the naming convention you have in your organization, you can pick that. I will stick with Z_CL and say okay, sample. So we'll make it 02. Now here I can say sample class as description and keep everything else as default. and go to the next section where we select what is the transport request I want to add it. Keep the default transport request where we are adding all the objects and finish. Now what I will see here is one more class get added, and this is z_cl_sample_02. Now you see certain syntax which is already written within the class. Now the class name and the definition, and here we have the implementation. Now you see two parts. The first is the definition and the second is the implementation. And in the definition part, we are defining what are the things which are present within the class, what kind of class this is. And in the implementation, if there are some methods or functions you can call, but more accurately methods which are present within the class, then those method implementation will come under this implementation section. Now here in the definition part, there are some keywords like class, the class name and the definition. And the first is the public, final, create public, then public section, then protected section, and then we have the private section. Now first we'll talk about these three sections, the public section, the protected and the private section. So the accessibility within the class can come into these three sections. One property or attribute or method can be inside public, protected and private scope. So wherever you have something inside the public, then it is accessible outside the class. Now I can use the attributes. So for example, here you have methods. You can see in the right hand side in our previous training class, ABAP training _24 class, we have this method, and similar to method, there can be properties like the variable which are present within the class. So those variables will able to be accessible outside of the class with help of objects, or directly with the class name we can access. So how to access that we will see in a moment, but whatever is defined inside public section will have visibility or accessibility outside the class. In the protected section, if we put something, those part will not be able to be accessible outside the class. But if there is certain subclass, so if there is one more class which inherits from this particular class, so if this subclass is inheriting from this particular class, then this subclass will have access to those protected section. Now the private section will completely be not visible. It will not be visible outside of the class with objects or to the subclass. These private sections can only be accessible inside. In the implementation, you will be able to use those. So this is totally hidden from the outside world, the private section of the class. The protected section is partially hidden because it will be accessible in the subclass, and the public section will be visible completely with the objects. With the class name, you can access the class methods and class properties, and also in the subclass, the public sections will be accessible. So these are three different types which one need to understand while dealing with the class. Now we also have this final section. Now this final keyword, if I add this within the class definition, then that means I cannot have any subclass which can derive. So no subclass can inherit from this particular class. All methods which will come under this public, protected or private section, which you will see in a moment, they cannot be redeclared in the subclass. So the concept of the final is that you cannot have a subclass inherit from the main class. Now these are optional. So if I try to also get rid of this final, that will be also okay. Okay, so for example, if I don't use final, that is also okay. So that means that this class can have other subclass inherit from it. Okay, now let's try to create method within this publish section. And in the previous section of function module, we have seen that function module will have importing, exporting parameters. So similar to that, we have here as well. So I will create a method here, sample add, and I will say that okay, it's having importing parameter of the first number, type as integer. So this is a sample add where, or just I will say add to number. So this will be the name of this particular method. So it will take two numbers and it will add those. So it will have second underscore number and type as integer, and it will take two numbers and it will have an exporting parameter and it will be sum and type integer. Okay, so if this is the method which I have, and you can see that it is similar to what we have in the last section, the function module definition. If I open that, if I open the function module inside the function group, it's having a similar syntax. If you see importing, changing, and exception, so these are similar syntax what we have, importing, changing, so importing, exporting. So similar to that we have the importing and exporting, and the meanings are also similar. So the importing is what this particular method will receive, and exporting is what this particular method will output. So when you call this particular method, you have to basically accordingly pass the importing and exporting parameters. Now also one thing which we need to keep in mind is that this first number and second number, when we passed as importing to the method, then they are actually by default passed by reference. So if I don't have this value keyword, then this will actually be passed by the reference. So now if I pass the value keyword, then only the value of that particular first underscore number is passed to this method, that is passed by value. And if I don't mention this value keyword, then it is passed by reference. Okay, let me just pass by reference, which is the default way, and I don't have the implementation now, so it's giving me a error, and I can click on this particular bulb or error and it will say okay, add implementation of add to number. So I will add this implementation, or once I click it, automatically the implementation is added, and this is a blank implementation. So within this implementation, what I can do is I can say okay, sum equal to first underscore number plus second number. So that is what the output is. So if I save it, then what I have is I have this simple sum, which will be the addition of the first number and the second number. And what I will do is I will try to use this particular class method, and let's keep the scope for the first example simple. And here I will come to a different main, or here in the main method, let me just get rid of this in the main, and I'm going to create an object of this particular class. And the way to create object is I can say data, and I will say sample obj equal to, and here I'm going to use the new keyword and the class name and the round bracket start and the end. So it will give me the object here, and what I'm going to do is use this object, and to access this method using this object I have to use the arrow, and I can use control space, or automatically it will show me what is all the methods and the property which this object can access. And you can see add to number is accessible. It has two importing and one exporting type, and I can click on this particular name, and here inside the round bracket I have to tell what are the exporting parameters I can give. So I can say okay, first underscore number equal to maybe 10, and then second I can use control space as well, second number equal to 20, and importing control space. And control space actually helps you to get this context help, and I can say okay, sum equal to, I can create an inline declaration, and say sum, so value, just to differentiate, okay, what we are getting. Now that is a total syntax, and I can arrange it in a readable fashion, so the code is readable for developers who are maintaining this code. So first is exporting, then we have the importing, and we have sum, and we have the output, and we have the end of the statement. Okay, and I can just out.write here the sum underscore value. Okay, so what you can see here, that it is similar to the function module. Whatever the importing we have within this method, that will be the exporting part from our ABAP code where the method is getting used. So here the importing means the method is going to receive those. So here importing is that the method is going to receive, so that will be exporting. So it will be exported and it will be importing for this method, and whatever the exporting we have will be the importing for the usage, where in the ABAP we have use of that particular method. Okay, so that is the scenario here, and finally I'm just printing that particular sum in the console. Okay, so let's keep this first example simple and activate the code and run the code. So I get the value 30 because the sum of these two numbers are given back to sum underscore value, and there we have the sum as 30. Okay, so this is the basic creation of a class and how can we use the method of that particular class. Welcome back. Now in the last section we got a basic idea about what is class and what is method and how to create a sample object and call the method from our ABAP code. Now there are a few things which we have not discussed, like what is this public keyword, what is this create public keyword, and just to discuss on that briefly, the class here what we have is the global class of the entire class pool. So I can also have class, like if I copy the definition and implementation and go to this local type, then I can also have one more class here, and I will remove this public and just to make this definition to match to the class implementation. And you can see that there is one more class definition and implementation. Here the public keyword is missing. So similar to that, I can have multiple class within the local types. So let me just copy this and I'm going to add one more, and I will call it 023 and also 23. So there is one more pair. So first is z underscore cl underscore sample underscore 022 definition, and then we have the implementation, and then this 023 definition and the implementation. So within this local types I can have multiple class, and these all class are referred as class pool, and within that all class there should be one class which is the global class, which is what can be accessible outside of this particular class name. Then that should be the class which should have this public keyword, and in this case in the global class tab, this particular class z underscore cl underscore sample 02 is the public class. Therefore we have mentioned here the public keyword. Now if I switch to the local types, then you can see that within this definition I have removed the public keyword. So that is the meaning of public. So that is the one class which is the public class or the global class for the entire class pool. Now the next thing is, what is this create public keyword? Now when we have this create public keyword, that means this class object can be created anywhere. Here in this case we have created the object sample underscore object of this particular class within the ZABAP training underscore 24. Now, similar to this, I can create the object in other packages also. If this class visibility is present, then I can create object of it. Now I can have, instead of public, if I do control space here, then I can have protected. So if I say create protected, then the object of this particular class can only be created within its subclass and also its friends class and also within itself. So within the own self or within the class itself, I can create the object of the class. So the places where I can create the object of this particular class is reduced. So if I activate this code now, so the class got activated. And if I try to do some changes within here, within the class where I'm creating the object, then I see that I get an error. The instance of the class can only be created within the class itself or within one of its subclass. So with this create protected, I can only create the object of this class within subclass or friends class or within its own class. And if I have the create private here, so what it means that the object of this particular class can only be created within its own class or within its friends class. So the private have more restrictive scope, so only friends or itself. Okay, so this was two keywords what we saw by default created apart from the final keyword. And what I can do is I can then also just delete this code which was created for the explanation. Okay, save it and also come here and revert this to public. So these were two things which we discussed. The first is the public keyword here, which was by default coming, and the create public keyword, which was by default coming. And let me activate this code. And here, if I activate with the create public, then if I just do some changes here, then this error will disappear because now it is of public scope, so that I can create object anywhere the class is visible. Okay, I hope that these two things are clear. Now, one more additional point we want to add within the method is that now this exporting parameter what we have is introduced with the 7.4 syntax and also the changing. So we will see the use of changing. So changing parameter also was introduced with the new 7.4 syntax with the exporting. And previously we only had the importing and the returning parameters. Now we have exporting, changing also added with the 7.4. Now what we'll see in a simple scenario is the returning. So this returning parameter was previously present, and what it does is it returns value. So let me say, okay, instead of exporting the sum, I can actually return this, the value of it, not the reference. So I will say, okay, sum, and I can say type integer. So if I define the method where the importing is the way to take this two number, and we know now that the first number and the second number is given to this particular method as a reference by default, and if you want to pass it by value, then we have to then use this value keyword. So by default it is passed as a reference, and one of the disadvantage of passing by references, in case we want to change these two numbers, for example, let me keep the first number as the first number without the value. So let me just demonstrate this with the first number. If I have this first number given as the reference and the second number given as the value, and let me just activate this code, then one thing which I will not be able to do is change this first number. So inside this method implementation, I cannot change the first number. So the first number is passed as 10, and within this method, if I try to make this first number as 15, then this will not be possible. So you can see in the error, first underscore number cannot be modified. Now the reason is that because by default, if I don't pass the value keyword before it, then it is passed by reference, and therefore within the method implementation, I will not be able to change the value of it, or it is not allowed as per the syntax. Now what I can do is I can change the way to pass this is with value by using this value keyword before it. So now the first number is passed by value, and I will be able to change the value of the first underscore number within the method implementation. Okay, so that is one side note. Now what I can do is the sum is something which I will give by adding these two numbers, and this is now the returning parameter. So how the returning parameter will be used? Now importing in my ABAP code, what I have to do, I have to create one more variable which is sum underscore value, and this is what will be returned from this method, and it will get stored in the sum underscore value. Okay, let me activate this particular object and activate the ABAP code to check. So activate the object and also activate the ABAP code, and I will run the ABAP code. So clear the console and run the code, and I see the same value as 30. Okay, so this is how you can get the returning from the method, and also when you pass by value, the values are passed as a value, not by default, which is passed by reference, which you cannot change within your method. And this exporting and changing parameter type are something which is addition in 7.4 version of the ABAP. Now, before we actually move forward, I would like to show you one small variation which you can also carry out within the parameters here. So we have previously seen that the value keyword allow us to pass here the parameter as a value instead of reference. Now you also have the keyword reference. So I can say reference, and this first number will then be reference. So I have here a integer OP1 operator, and which I can pass as a reference. Now this first number you cannot actually change within the code, so I cannot really change the value here because it is passed as a reference. If I try to change it, then I will get a syntax error. Now the first number is passed as a reference, and I can use that within my method here. So if I try to activate this code and just run this code, then you will see also the same output. So let me run the code, and you can see that the field of the sum 10 and 20 is coming out to be 30, and I have also printed the OP1 operator 1 after that, which is the value 10. Hello and welcome back. In this section, we will continue our discussion with object-oriented programming with ABAP. Now, within this section, we will start the discussion of inheritance. Now, first of all, why we need inheritance in first place and how to perform that in our OOPS ABAP, we will see that. Now, when we inherit from an existing class, for example, here ZCL sample02 is a class, and if we try to inherit from this particular class, then we will be having access to its method, its property like the data here, and also the static or the class data and the static methods or the class methods. So these all will be automatically be present within our new class if we try to inherit from this particular class. Now you can easily see that I don't have to then copy the code to use the code. I can just inherit from this class, and this provides a nice way of code reusability. Now that is one of the main reasons why you will see the use of inheritance. The code reusability comes into picture automatically when you use inheritance. Now, when we have the properties and methods which are part of the public section, and protected section, then only those particular properties or methods can be inherited in the class which is inheriting. If we have something in the private section, then the inheritance will not be able to have access to those properties and method. Okay, so this was a theoretical background of it. Now what we will try to do is we will try to create a new class which will inherit from this ZCL sample underscore 02, and we will see how with the inheritance I will have access to the first number, the second number, and also with the inheritance, when I create object of the new class which is inheriting from this particular class, then also while creating the object, the constructor of the superclass from which the class is inheriting, we are referring that as a superclass, the constructor of the superclass is called. So we'll see that now. Okay, so let's create a new class. So I will right click here in the class, new ABAP class, and I will call it ZCL sample. Let's call it underscore 03, and I will call it a sample class. So just a sample class, and next and finish. Now within the definition of the class, I have to just write after the definition inheriting from, and here I will say, okay, what is the class? So I just close this class and other interfaces as well which are not required, and there are too many things opened, and I will just copy this name from where we are inheriting and save it and activate. Okay, so by just writing inheriting from, we automatically will have the access to all the public and the protected section. So what I can do is I can create an object of this sample underscore 03. So if I go to the main and I'll say, okay, data sample obj 03, and I can use new and the class name. So just the class name, and when I try to do that, when I create the object with the new, then I will have to also pass the first number and the second number, which is basically the importing parameter to the superclass constructor. So if I see the problem here, then you can see that the first number and the second number is not passed, is what we are getting error. So if I try to pass the first number, let's give it a random value 20, and the second number and give it a random value as 30, then we don't have that error anymore. The error is gone. Now this is because we are basically calling the constructor of the superclass when we create an object, and from this particular object you can access the first number, the second number, and also the add to number methods, and also the class data and class methods. So if I try to just out.write, and I'm going to use the object and arrow, and I can access the first number, the second number, the sample, which is the class data, and also the add to number method, and sample change, which is the class method. So all this I can access because I'm inheriting from the sample 02 class. So let me just try to access this first number and second number, and let's see what is the value we have. So first number, and here second number. So save and activate and run the code. Let's see what we get in the console. So I get 20 and 30. This is what the value which I provided, and this value are then assigned to the first number and the second number property. And if I try to also call this add to number, the add to number is having a returning some value, so I can directly write that as well. So if I say sample underscore 03 add and to number, and here it will have the exporting parameter. So from the main we have to export because here it is importing. So I can have first number, let's have it as 40, and second number, and let's have this as 30. So if I save, activate and run, because we are having the returning parameter, then add to number basically will return the value which we are just doing out.write. So let me activate the code and run the code, and you can see that the sum is coming out to be 70, and here 20 and 30 are basically the first number and the second number value which is getting printed from line number 60 and 61. Okay, so this is how we can inherit from a particular class, and once we inherit, we have access to its public and protected sections, which is the properties and the methods. And when we try to create a constructor of the class which is inheriting, then it will also call the superclass or the class which is the parent class from where it is inheriting the constructor of that particular class. Now, if the constructor has certain importing parameter, then you have to mandatory pass those importing parameters. Now the question comes is, now what if the new class sample03, which is inheriting from sample02, what if this class have a constructor? Then will it call the parent class constructor, or what will be the scenario? So we will see that in the next section. Hello and welcome back. In this section, we'll understand some of the advanced concepts related to OOPS ABAP before we actually use those in our code and demonstrate. So let's proceed and see what are those. So the first thing which we will try to see is what is upcasting and downcasting. Now we have already covered that in case of reference, but now we will showcase this in case of OOPS ABAP. So here we have one class called CL_bird, and this class have one method called canFly, which will tell you if the bird can fly or it cannot fly. Now this will be our superclass from where we have two classes which is inheriting. One is the penguin, the CL_penguin class, and the penguin class has one more method within it called swim underwater. So once you call this method, then the penguin will actually start swimming underwater because penguin can swim underwater. Now there is one more class which is inheriting from the bird, which is the CL_parrot, and the parrot can talk like a human, so we have a method here, talk like human. So that is the structure, and these two, CL_penguin and CL_parrot, are subclass which are inheriting from CL_bird. So what will be the scenario is, because these two classes are inheriting, then they will also have access to canFly method of your CL_bird. Now what you can see here, that the bird is actually a generic class, and when we inherit, then we are basically inheriting in a more specific class. So the penguin is a more specific bird and parrot is a more specific. So bird, you can say, is a generic set, and within that set we have penguin and we have also the parrot. So these are two generic. So this is the generic, and here when I say parrot and penguin, then I'm being more specific. So in real world examples also, you will see that the superclass are more generic and the subclass which are inheriting from the superclass are more specific. Okay, now using this information, I want to talk about the casting. Now, when we talk about the casting, for example, we have an object of class B, and here the B refers to class bird. So this is bird class object, and this is object of P, which is, it can be an object of penguin or can be an object of parrot. Now, whenever I'm trying to change the object of penguin and trying to assign the object of bird, or converting a penguin object, and within this obj_p, if I'm trying to equating it to the obj b. So what I'm trying to do here is obj underscore penguin, converting it into obj underscore b, which is your bird. So when I'm trying to convert the subclass to the superclass, then this is called upcasting, or also as widening cast, because I'm going from a specific, which is the parrot and the penguin are specific case of a bird. I'm going from a specific example to more generic example, which is the bird. So this is called upcasting. And the opposite, when I'm trying to make the obj underscore bird and I'm trying to assign here the obj underscore parrot or penguin, then this is called downcasting, when I'm narrowing down the cast, or I'm going from a generic, the bird, the generic, to a specific, which is the parrot or the penguin. And within our hands-on examples, you have also seen that z underscore cl underscore sample 02 is the superclass, and the z underscore cl underscore sample 03 is the subclass. So we will see in the hands-on the example of 02 and 03. Okay, so this is the upcasting and the downcasting in theory. I hope that it is clear. Okay, so let's move on to the next thing, which is what is static and dynamic. Now this keyword static and dynamic, you might have heard a lot in your OOPS ABAP, and what they actually refer is the class or the interface is static type or referred to as static type, but the reference or the object is referred as dynamic type. Now the static type are more general version and the dynamic type are more specific. Now what we will also do finally is cover the is instance of functionality, which is present from the 7.5 version of the ABAP, and why the is instance of functionality is used. Now the is instance of functionality is used to first of all check if the object you have in the LHS is derived from the class you have in the RHS. So that is the first scenario which you will use the is instance of. You want to check if the object is actually an instance of the class in the RHS. So within this example, we have two classes, CL underscore A and CL underscore B, and from CL underscore A you have an object obj underscore A and obj underscore B. Now in the first scenario, when the is instance of will give you true is if the class in the right hand side is the same class out of which the object in the left hand side is created. So that is the scenario 1 where you will get true out of the is instance of. And the second scenario will be where you have the CL underscore B a super class. So this is the super class, and out of this super class, the object in the left hand side is out of one of any subclass. So you will say that the CL underscore B is the superclass, and you have the CL underscore A as the subclass, and the subclass CL underscore A is inheriting from CL underscore B, and out of the CL underscore A you are creating an object obj underscore A. So this is instance of will give you true in those scenario, because in this scenario it will check if downcasting is possible. What I mean by downcasting? Downcasting is when I can create an object of the superclass. So if I can have obj underscore B and I can assign this to the new CL underscore A, which is the creating an object of A and assigning it to B. So if this is possible, which is downcasting, if downcasting is possible, then it will give true. Or in a simple form, what I can say is, if I can assign the left hand side object into the object created from the right hand side class. So if this can happen, if I can basically assign this obj_a into this object which is created from the right hand side class, then it will give true. Okay, and it will give false if it is not possible or the downcasting is not possible. Okay, so that is the reason why is instead of is used in the ABAP code, which we will also see in many examples. And also you can do the same thing with the reference here. And when you do the same thing with the reference, that means in the left hand side you have the reference of A, and you are basically checking with a static type class CL_B, and it will give you true if the reference is the reference of the CL_B, if it is created from the CL_B. So that is the first case. And the second case, if you can basically assign the reference of B. So if I create a reference of B and I can basically assign this to the class, whatever the class this reference is created from, I can assign an object from the class from where this reference is referencing to. So if this is a reference of the CL_A, then I can create an object of CL_A and assign this to reference of B. So again, this is the downcasting scenario. If it is possible, then it will give true. And if it is not possible, if the reference of B cannot hold the object of A, then if it is not possible, then it will give us false. And if you try to do that, then it will give you a casting error, or it will throw this casting error, or to be more specific, CX_SY casting error. So we'll see that in more details in the hands-on section. Okay, I hope that this concept is clear. We went into a little more technicality of the is instance of, and it basically checks if we can have the downcasting, and if downcasting is possible, then it will give true, and if it is not possible, then it will give false. So that is the in short explanation of its instance of, which we will also see now in the hands-on. So let's go into the hands-on section to see this concept in much more detail.